Hi everyone, we're going to be talking about charging by friction today. And the first thing that we're going to do is go to page 8 in our packets, and we are going to talk about how someone obtains charge when they shuffle their feet on a carpet. So this is kind of the second half of our question of why do we get shocked, and kind of why that happens. It's because we are charged. We have to be charged to be grounded. So we're answering today, how do you actually get that charge? How do you get it? So we know that the insulated sock, cotton is an insulator, carpet is an insulator, and so that means that they both restrict the flow of electrons. They both start neutral, right? Things don't really start charged. And so because they have 10 atoms each, they will have 10 protons, and because they're both neutral, they will have 10 electrons. So what you're going to do in your packet is you are going to write that down, and you are going to add 10 neutral atoms to each object, to the sock as well as to the carpet. You can pause the video if you need a little bit more time, but I'm going to move on. All right, so we are going to start with given information, the same given information. So given that both the sock and the carpet start neutral, we always start with the initial charges. And we know that neutral objects don't attract one another. And so if we bring two neutral objects close to each other, there's no reason for electrons to move, right? There's three reasons that electrons move. One is that electrons are attracted to exposed protons. Another is that electrons are repelled by excess electrons. And there are no exposed protons in either of our models, and there's no excess electrons in either of our models. And so neither of those reasons can be the reasons that electrons move. And so the objects are not going to be attracted or repelled from each other. But this scenario is special. This interaction is special because we know from some of the demos that we've done and from just our own lived experience that when you shuffle your feet on the carpet, or when you rub a PVC pipe with rabbit's fur, things become electrically charged. And so there's something special about the fact that the sock is rubbing on the carpet. And then we've also talked about a third reason that electrons move. We, wrote it in our packet on page 2 and haven't come back to it. And this is where we come back to it. So the sock has more electron affinity. This means, and that's just given information in the prompt, in the model. So the sock has more electron affinity. So that means that electrons are going to move from the carpet to the sock. So higher electron affinity in everyday life, we would say something like, Miss Ruda has an affinity for science. It means that I like science, I'm pretty good at science. Like, if you have an affinity, it means you have this natural liking for that thing. So when an object like a sock has more electron affinity than the carpet, that means the sock likes electrons more. It'll take electrons. And so electrons are going to move from the carpet to the sock because there's this rubbing interaction, this friction. That's why this is called charging by friction. And because the sock has more electron affinity, they go from the carpet to the sock. So now we need to draw our models. Well, if the sock has a charge of -3, that means that the sock will have 13 electrons and 10 protons. But where did those electrons come from? The sock gains 3 electrons. Where did they come from? They came from the carpet. And so we need to draw that. So if you notice now there are 7 neutral atoms and 3 with an extra electron. There are 7 neutral atoms, but 3 atoms without an electron, with a missing electron. So we still have a net number of electrons of 20. So before we had 20 electrons, 13 plus 7, still 20. So we still have 20 electrons. And you can tell that the sock is an insulator as well as the carpet because those electrons are in the same spot. So neither of them show those electrons spread out. The electrons are in the same location. They're close together. They're restricted. So this is called charging by friction.